So Inder is here. He's a founder and CEO of Alicia Boats, and we have one of the units outside for you to look at and even play a little bit. So there is the unit that attaches to the vessels. There's a long cable that goes to a sort of a suitcase type of device with a computer, and then there's a remote control, which is essentially like a PlayStation joystick that you can use to maneuver the device. So after this, we can go out and play. It's kind of big. We didn't want to have it here on stage. So I met Inder. I guess the first time we talked was back in February of 2024. He's Indian, and his company was in Singapore. We were connected through the Boston network. But he has a very remarkable career because he started as a marine engineer, and he's actually worked in vessels, as an engineer. And in fact, Alicia Boats is his second company. The first company was called Tres Solutions, right? Which in the predictive analytics, so there was IoT sensors in vessels that helped improve the performance of the vessel. And Inder oversaw that company from bootstrap to exit, and I guess it was from 2016 to 2020. I'm just looking at my notes. And it was sold to Navtor, which is owned by Axial KRR. So he already had this experience of building a company. I think the exit was around 2030, but I forget the precise number. And so Alicia Boats is a second company. In fact, we visited in October with Melina the facilities in Singapore, and we closed investing in December. And it was a co-investment, by the way. It was 4.8 million. We led around 2.6. Stolt Ventures, which it's a venture arm of Stolt, which owns several vessels, followed as long as with Utopia Ventures. So we're very impressed with the product. We'll talk about it. But first of all, I want to ask Inder. First of all, thank you for coming. By the way, I know you have a very busy schedule, and so I want to ask you, about your background and your sort of, how did you get to become entrepreneur? And I had Indian PhD students, by the way. My best collaborator at Columbia was an Indian student. We had most of my partners were with him. So there's a great rapport, like with Koreans. So, but your story is not like it didn't finish IIT, for example, right? You went through IIT is the Indian Institute of Technology. Okay, so it's a very well-known schools in India where people do engineering, go do PhD.
I'm actually through the IIT.
Sorry?
I'm actually through the IIT.
Through that? Okay. I thought it was a marine...
Yeah, but that was the special marine...
Oh, okay, sorry. I thought that was bad. Okay. So tell us a little bit about your
yeah, I mean, ever since the beginning, I think I always wanted to work on boats, ever since a child. And I think that manifested into me being kind of a marine engineer. And I think one of the greatest learnings as a marine engineer is, you get to work with your hands. You learn the skills of repairing machines, seeing how they perform. It's like a $100 million asset which is operated by just 4 or 5 engineers. Right? Mm-hmm. So that's the best experience you can get. And you're in the middle of the sea, you can not just call help. So I think that was one of the greatest experiences which I still treasure with me. I think, and I did that for a couple of years till I became a chief engineer. Mm-hmm. And then I joined Maersk in their research and development wing, and that was kind of a new school to me because I was introduced into the world of the data and what power data had. And eventually, I think, when you work for these large corporates, a lot of really great ideas either lose urgency or, somehow they are lost in the corporate world. So I think, that was the foundation of why I wanted to start a venture, and that's how I started Tres Solutions. Uh-huh. And so we actually had a very fancy tagline. It was called Data, Insights, and Solutions. And by the time the company matured with data and the insights, it got acquired. Otherwise, we would have actually built the solutions. So now we are building actually the solutions. Okay. And that's how the journey of Alicia Boats started, where what was the market really needing at this point was a kind of a small hull grooming device. Mm-hmm. Because if you see shipping as an industry, they're wasting 37 million metric ton of fuel each year. That's around $25 billion of fuel which is getting wasted, and that's just because of one problem, hull fouling.
Okay.
Yeah.
And so in Tres, by the way, did you build your own hardware at Tres, or you used off-the-shelf sensors and so on?
We had off-the-shelf sensor, so I think that was actually quite easy. So this is so technically this is my second venture, but I treat it as my first because hardware is a completely different ball game. I mean, because I come from software and IoT sensors, which are off the shelf, but this is like actually building hardware.
Right. So, in fact, to me, this is very impressive. There are very few people, I mean, these days specifically, who can actually produce both hardware and software devices, okay, for better or for worse. And of course, this is the heart of engineering. I mean, that's what everybody should do. But the complexities of like designing your own electronic circuits, writing the driver software, writing application software, it gets very complicated. So it's very hard for somebody to basically get the skills to do that right. And you did. So tell us a little bit about the beginnings of Alicia Bots, because I'm sure it must not have been easy, right, to jump into a complicated device. And mind you, the marine environment is one of the most challenging from an engineering perspective. I mean, you have devices in salt water, right? They have to be waterproof, and they're subjected to torture, right? Mechanical torture. So tell us a little bit about that, because it'll be easy to say I give up. I mean, it's too hard, right?
I think when you talk about robotics, right? Robotics is tough in general. But what's tougher is like underwater robotics. And within the underwater robotics space, the toughest is something in saltwater and the marine or the ship-related environment, because the dynamics are changing so fast. And, it's although the ships may look alike, when you see it at a very detailed level, it's not always the same. So yeah, I think I genuinely had an interest in hardware, even since my days at Tres. We were trying to build a lot of hardware in-house itself. I think that's where some of my journey started. And then, like since 2020, I was quite actively focused on, like going back to the drawing board and learning each and every single component. And during those days, I think one of my mentors, Captain Sanjay, I used to have discussions with him, and he taught me a new definition of IPO. He said that it's called input, process, and output. So like what output you want, you select the right inputs for that, design a correct process, and you'll get the required output.
Okay.
So I think that goes back into my drawing board, and that's how, what do I want to achieve? Like, I want to achieve cleaning only microfouling, only light level of fouling, and inspections on the vertical sides and the flat. So I think taking one step at a time, it took us a journey of 4 years, and we had something.
I was very impressed. This is not the only device, by the way, which is designed to do this robotic cleaning of hulls. And while we're doing the sort of due diligence with Melina, we're very impressed by the design choices that Inder and his team made. By the way, the device is impressively small. I mean, it's 23 kilos, which means 2 people can lift it and, put it on the side of the ship. You don't need a crane, you don't need some special facility. So maybe it's worth explaining to people who don't know, first of all, what fouling is, right? And then how the robot works. I mean, it has wheels, it attaches magnetically. These were all carefully made choices, right, that result in a very, very, very competitive product in terms of capabilities. Okay, maybe you want to say a few things about that.
I think that's where my background as a marine engineer comes into play, where being a part of the ship's crew, what are what are their requirements, what are their difficulties, and how you need to address certain challenges. So first of all, hull fouling is like the underwater area of a ship. Over a period of time, it becomes a colony of microorganisms. These organisms, they start growing in nutritious waters, and they build up over a period of time. And as they build up, it makes the ships a little bit slower. Either it makes it slower, or if you want to get the same speeds, you would start over-consuming fuel. And most companies, if you see, take a decision of cleaning this kind of fouling when they are over-consuming by at least 10 to 15%, because with the existing reactive methods of cleaning, which are available in most ports and diver-based cleanings, it's that's more feasible. But what we wanted to achieve as an objective was to clean at microfouling levels, because it's easier to clean early stages of fouling. And you protect your paint. It does not cause substantial damage to the paint, because if you're cleaning heavy fouling, it's going to damage the paint as well. So I think that was one thing. And then, our general mindset is like, if a ship's crew needs launching arrangements or winch arrangements for deploying any equipment, it's a natural, you lose the buy-in from them. So I think that was one of the reasons we wanted to make it lightweight and achieve the same functions of cleaning at least basic levels of hull fouling.
But then, it has 4 magnetic wheels, permanent magnets. In fact, you can go and play with the magnets because they're extremely strong. And you have to be very careful when you handle the wheels, because you can really damage your fingers by how strong the magnetic field is. But then, it has rotating brushes, right? Yes. That as the robot moves, they're rotating and sort of groom the hull. And what is interesting to me is that the robot is tethered. So there is a cable, very long cable, right, through which you go to the control station, okay? And there are some companies that, they use a wireless version of something like that. But in reality, with the wireless is very problematic underwater. And with the tether, you have access to very high bandwidth, so you can have cameras and other types of sensors. And you also have a mechanical device. If something fails, you can pull the robot back into the ship. If it's completely wireless, it can disappear if something goes wrong. So I think these were like very, judicious choices that make this, an extremely sort of great device.
I think the choice of the wheels was quite natural, because if you ask, most of the people in the room. If they can drive a car, I think 90% will say yes. But if you ask most of us that, whether anybody can fly a plane, maybe only 1% or 5% would. So I think the wheel version was because we wanted the crew to drive this around the hull quite easily. We could have used alternative thrusters as well, but then that would restrict its movement only in certain type of waters, or where the currents are less, or that would restrict the movements that you cannot carry out an operation when it's sailing.
By the way, I understand there is no Starlink also connection on the robot itself. You can even remote operate it, right? So that's actually very exciting, which is completely separate from other types of IP connections that the vessel may have with Stream, because you don't mess around with all the IT infrastructure.
The standalone Starlink itself, and it's on a lease model.
Right. Let's come to Greece. In fact, Inder inaugurated the Greek sort of production workshop here in Koropi, and we were there May 30th. There were 70 attendees from 35 companies. I mentioned it earlier. There were 2 paint manufacturers, JIT and Nanophos. Nanophos is a Greek company that makes marine high-performance marine paint, and the beauty is that this type of paint requires Elisa Bott's robot to do the grooming, right? Because it does have anti-fouling properties, so you have to keep the paint clean to make use of its hydrophobic properties. So these two go hand in hand. So it appears the path is clear that the direction is to combine high-performance paints. By the way, it costs $500,000 to paint a ship. It's not a cheap exercise. And it's also costly because the ship has to be in dry dock, right? So that's another thing. So this was great. By the way, Inder sold I think 9 units that day, so that was good. And so it was the beginning of a Greek journey for the company. So talk to us about that. We were very happy to have you. Alicia Bots is the first investment of Big Pie where there was no Greek on the team. Okay, and this was just because Inder wanted to come because of the obviously of the Greek interest in shipping. Now there are many people on the team. In fact, the CFO is great. Claire, which is somewhere here. Yeah. So we're building up, the capacity here, and it will become the dominant production side for the company. In fact, Inder was telling me that 80% of the parts he can source here in Greece. I was amazed because I thought we didn't have a startup capability in parts that are used in these types of products. So there's only 20% that comes from China, but the rest is either sourced globally or 3D printed in the facility. So tell us about Greece. Excite us about, how great this we are.
Yeah, I think Greece was definitely a natural choice if you see that majority of our customers are there. And plus, I think Greece has one of the largest shipowning pools in the world. So it was very natural. But I think that was not the only prime decision. I mean, we evaluated a couple of other places also, like Rotterdam and Scandinavia. But the thing is, I think one is getting, 80%. I think that was the first thing to identify that if we can source all our components, because we wanted to import the least amount of components over here due to certain processes in the import
export, I guess. So once we found that, and then I think real estate was also, quite within our budget, I would say. And plus, it has one of the, the ship repair background, or easier to find, talent from the shipping industries. I think that was one of the key decisions which made us that it would make it more worthwhile to have your production unit in Greece.
Yeah. By the way, there is an international conference on underwater robotics in Syros in June. Okay, complete. So apparently there is a lot of stuff happening in the space and also specifically for Greece. But how many ships are you deployed right now? I think it's 90.
So we have an order book of 95. We deployed on 69, close to
69. Okay, great. So shipping has had a reputation of being very conservative. Okay, we looked at several sort of shipping companies as Big Pie, potential investors. We never really did anything there. In fact, Alicia Boats is the first company. Part of the problem was that it's hard to scale technology in ships. Obviously, the shipping business is a huge business. But the business of selling technology to shipping, that's not necessarily a great business. And obviously your first company was great, but Big Pie would not invest in a company that would aspire to exit at 30, 40 million, okay? We mentioned earlier, we really want to invest in companies that can become, billion-dollar companies, fund returners. So tell me about your perspective about the shipping. My perception, and I'm new to the shipping business, it seems that this sort of mentality of being very conservative is changing, isn't it?
It indeed is changing. If you see during my last venture, I didn't have a single Greece customer.
Not a single Greece customer?
Not a single Greece customer. And I think that had its own different reasons. But this time I wanted to be sure, so I took the right decisions. But I think, in the last 10 years, what I see as a pattern change is now I think more and more companies and their technical departments are more forward-looking when it comes to technology. It's easier to adopt, and they at least want to give it a try. So that made it a little bit easier for us. And then, of course, as your equipment starts proving value, it definitely makes sense for them. And plus, I think the technical departments are more solution-oriented. So if you're providing an equipment which gives them that instant solution and not just data and insights, I think they're more willing to adopt.
I think also the introduction of robotics in general in ships makes a lot of sense. Ships are huge, right? 100, 200 meter long. You might need a scooter to go around. And they have workflows in very dangerous places, and this is perfect for robots. So I think part of the excitement I think in the Alicia Bot story is that you're starting off on a journey where these robots can do a lot of other tasks besides hull cleaning. Cargo hold cleaning is a very active project that you guys are looking, right? So you have the robot cleaning the cargo hold where you put whatever you're carrying, and also doing inspections, which you routinely have to do, and these are very dangerous environments. So this is a perfect place, right, for application of robotics, right? Not just for the hull cleaning, but really for everything that's going on in the ship, right?
I think we have identified around 22 areas where our robots or similar robots can actually work on the ship itself. And I think we are taking one step at a time. But I think the key challenge was the underwater. Once that was sorted, then we know that the other areas are fairly much more easier. We're doing, in fact, some steel thickness measurements, underwater surveys, asset integrity reports. So quite a lot of ad hoc services using the same robot itself.
So we always talk about AI, all right? And obviously AI is a perfect place to use in robots. So how do you see AI playing into the Alicia Bot sort of product roadmap?
So in the product roadmap, we are actually testing something where we are trying to predict what kind of fouling is going to be on a particular trade route by analyzing some of the images which we have collected from ships on that trade route itself. But I think it's at a very early version because there's no substantial underwater ship hull fouling data precisely. Like, I mean, if it would be for any other consumer product, you have those kind of data sets easily available.
Right.
But this is like, it's our own data sets which we are trying to train the models. But I think going forward, we want to give the user a kind of an idea that if they're in a particular trade route, what is the chances of the fouling, how their fouling is going to develop, and at which point they should be.
I was also thinking along the lines of like fully automating the robot. So no human operator. You just, put it on the side, click go, and then it just scans the vessel and self-learning, so to speak, that routing. Is that something that you see happening anytime soon, or?
That's actually, in terms of tech, it is available. But the thing is, like, there are also certain safety concerns. Like, for example, if there is to be that, 1 in 100 situation where a ship is sailing and the robot gets stuck, somewhere, and you have to literally call a salvage team or a dive team, it becomes so expensive that, and that was the whole reason about the tether. It's actually, we can make this tetherless operation, but the tether is that if there's that 1 in 100 incident, if the robot gets stuck, you can actually just roll it back to the deck.
Okay.
So
okay, yeah. I have two more maybe questions. One is so what is your aspiration for Alicia Bots? Where do you see the company, in 5, 6, 7 years?
I've actually, I've not thought about it 5, 6, 7 years, but in 2 years. I've thought about, what are the numbers I really want to achieve. And I want to, get to, I've set targets for myself and the team that these are the kind of number of ships we need to get to, or in terms of revenue. And I think then, once we are close to that, then it's the next step. It's one step at a time.
It's a healthy approach. I mean, nothing wrong with that. Now, let me ask you something, I guess, more personal. I asked Christos Trifonas the same question before. Joking that if you want to be successful in businesses and make money, you run the risk of aspiring to become Elon Musk, okay? Or if you want to be successful in politics and public service, you're going to be aspiring to become Donald Trump, okay? So you got to be careful what you're aspiring to become. So what is success for you personally? I mean, how would you find success for you?
I think success for me is like, in my eyes, the journey has to be worth it, and for other people, the book should be worth the read.
Sorry, the what?
The book should be worth the read.
The book should be worth the read. Okay.
So that's how I define it.
Okay. Thank you so much. Thank you very much. Maybe we can take a question or two from the audience. Yes.
How many? You asked how?
How many? Yeah. To repeat the question was, we mentioned some other robots that are tetherless, whatever. So the question is, what is the competition and how many years have been they operating? And maybe you can talk about the competitive landscape in general, right? Yeah.
So generally, if you see in the competitive landscape, there are thruster-based technologies and there are magnet-based technologies. The limitations of thruster-based technologies are, they can only operate in certain sea conditions, like the sea currents to be less than 1.5 knots or less than 2 knots. Again, they will be, in most cases, it's going to be tethered. There are a few tetherless operations also, but tetherless operations do not give you the flexibility of having a live video coverage unless and until they have a kind of a floating beacon or something. Many of the companies are operational from 2016. Some of the big players like Clean Ship or Fleet Cleaner or Subsea Global, who have these huge ROVs, they've been operational for quite some time. But they offer like their business models are service-based models. They offer in select ports, whereas ours is more like a resident robot on board the ship, which gives the flexibility of operating it across various ports as well, and also the infrastructure cost is substantially low. I don't think, you see, in general, like, I don't think there are any barriers for entry for the competition. And, they would probably, at some point, they would definitely get in. I think what our whole research has been is like, bringing in, so there is something like innovation in technology, but there's also innovation in cost. And I think, bringing low cost, to technology, I think that has been our key focus in 3 to 4 years, right? So it's easier for a competitor to probably, come in the same cost bracket. But I'm definitely sure that it'll be hard for them to beat our margins, I would say.
Yeah, look, always when you ask a super bright and capable person, is it easy to do? They'll say, of course it is, because it is for them. The reality is that they have built a unique product. They have the capability to design and build their own hardware, so they're ordering their own electronics. Right there, you start getting into, okay, how you do it. In fact, they even design it so you cannot reverse engineer it. It has fake layers. So even if you take it up, it will be very hard to figure out what's going on, okay? So Inder says it's easy, but let me tell you, my opinion is not so easy, okay? So they have built a competitive advantage in the design. They have the capability to produce original pieces. So this is not just assembling, I'm ordering 10 pieces from China, screwing them in and selling them. No. And so the combination of these factors, I think, gives them a very healthy headroom in terms of where they are. So I'm personally, I feel there is a very strong moat for the competition. Okay.
Yeah, of course, the hardware is entirely built in-house. Like every single component, I think maximum 5% would be off the shelf. Otherwise, everything is built in-house. If that was to answer, yeah.
Yes. Yes, that's a very good question. Do you sell it as a product or as a service? How do you sell the product?
Yeah, we actually lease it as a kind of product itself. So it can be used by the ship's crew. But we also have certain service modes, like in case your crew is busy, or then we provide the Starlink so that we can take remote access and give you a service as well. So we have kept that flexibility.
But when you order one, you take it for 3 years. You pay a yearly fee, right? As a product. So you sign a contract, right? You pay, I don't know what's the kind.
So it's a yearly fees for.
What is the MSRP these days?
On 3 years.
The MSRP, what is it?
It's a $30,000 each year, all inclusive, spare parts, consumables, and 4 services a year included. So this is, it comes like a package for 3 years.
And by the way, for those that don't know, the actual cleaning in a port with divers, I think costs about 30,000.
Yeah, it depends. Like, I mean, in Singapore, it would be 25 to 30, but if it's in US, it would be 45, 50.
And there is human risk, by the way. I mean, divers do get killed or whatever, doing the work. Sorry, there was another question.
I have a few questions as well.
Sure.
So when you rented this robot, you rent it for a specific ship, or you can use it on different ships?
It's for a specific ship, because a lot of the ship's hull plans and specifications go into designing the autonomy of the software, as well as see, this comes with hull cleaning and monitoring software as well. So
a company that rents that one has to use it on one ship only?
yeah, it's basically one ship for, yeah.
And the other question is, do you have a patent for that?
Do we? No, we have not yet applied for a patent, but I think going forward at some point there are a certain patents we would be applying for. But I think somewhere patents also disclose a little bit of information, which at the moment we don't want to.
I have a lot of history myself personally. On the intellectual property front, I have several patents on my name, and I've been in licensing arrangements. So this is an area of active discussion with all of our companies, by the way. And there's a trade-off between disclosure, because obviously patents by definition imply disclosure, so versus keeping something as a secret sauce, so don't allow others to do it. So it's something which is on a case by case. You want to.
Yes. Yes, we do that actually. Yeah.
Through Starlink. That was a Starlink.
That's why, it comes with a standalone Starlink subscription, so that it does not interfere with the ship's network. The crew has the flexibility to operate it, but we can operate it from our offices as well. Yeah.
And also, if you can do it while the vessel is on the go, up to what speed can this robot operate?
See, the robot can operate safely up to 11 knots, but I think your visibility is significantly impaired after 6 knots. So we recommend that, up to 6 knots you can operate it quite safely when the vessel is sailing. And that too on the vertical side, it's not near the propeller or not on the flat bottom.
By the way, we want to mention how many people are on a vessel, because it wasn't obvious to me, because these are huge machines. What is a crew size on a normal sort of vessel?
It varies from 19 to 22, I think, in standard.
And this is a whole factory. To me, that was like, wow, it's a very small crew, right? Any other question? We are over the time. We'll be outside, for playing with.